All good to go? How's everyone doing today? Just want to quick throw a question here. How many of us use some agentic tooling today? It should be all of us. I know we're all vibe coders. Follow-up question, how many of us asked these agentic tools a question we've already asked before, but it took a long time for some reason? It's going through our repositories, it's going through all our files, it's grepping, changing directories. It's being redundant. We had this problem this weekend, and we really want to focus on fixing that. That's why in 36 hours, we made one line of code. I'd be lying a little bit if I said that, but we made a kernel command for you guys to run and download our plugin. Our plugin is so good, it takes state-of-the-art agentic tools and decreases the inference time by 200%. I'm Alan, this is Adarsh, Ryan, and Caleb, and we are Autopsy.
Yeah, awesome. Just like Alan was talking about, there's so many amazing agentic coding tools right now. Claude, Codex, Windsurf. There's one kind of problem though. They're all stuck in a maze. You can clearly see they all go loops. They all do an exhaustive search to try finding the solution. But what if there was a map of every single wrong turn it made to make sure it never makes that wrong turn again?
So what is the perfect interface for this kind of application? We decided to go with open code, and maybe you guys know or heard of it. It's an open source alternative to Codex and Claude Code. And the reason for that is that it releases its traces and its thought process. We need to ingest that, and we use that in order to understand user sentiment and when rejections happen, and that helps for future models.
Yeah, so technologically, the main thing that we're doing is we're taking that entire trace in and we are searching for rejections. Rejections in this case are going to be things that can be a bit empirical, like linting errors or type checking errors, or they can be a bit more like how probably all of us vibe code, where it spits something out and you go, wow, that's terrible, change it, you suck. If that's the case, we do a little bit of sentiment analysis to determine that you aren't happy, that you're dissatisfied with it, and we use that to track a rejection. What happens with the rejections, however, is I think kind of the magic of our tool. So like Alan said, we really want to take those failures and use that as our blueprint to succeed in the future. So if you want to go ahead and open up the graph here. So with those rejections, we go ahead and build this graph here. I know it looks like a lot, but it's not too bad if you think about it. Pretty much, we take the agent, we take the issue that it had, or that it failed on, the symptoms from that issue, and then a suggested fix for that issue, and we graph that all in this big graph here. This is kind of where the magic happens. Every single call past this point, we consult this graph with a cosine search on our vector database to find a similar node to the user's new issue. Once we have that, we start at that node and do a graph search around the graph from that node, and we go ahead and gather all the context related to that issue. And then instead of just dumping all the context directly into the prompt, and blowing up your input context window, we go ahead and do the opposite, where we try to cut down on the output context window instead. So we take that little bit of context that we got from the graph, and we inject it specifically into the tool call right before it would normally go ahead and start searching your entire code base and repeating itself. And with that little kind of push over the edge, we've seen just amazing results from these models, able to immediately just skip most of their tool calling and put out an amazing solution with much better results than without the graph. Alan can tell you a little bit more about the stats you've been seeing.
Yeah, so testing with Anthropic's Claude Haiku is its worst model. We went from a 3-minute inference time, and using our plugin, we got it down to 1 minute and 6 seconds. Now going to the state-of-the-art Opus 4.7 that we all know takes up our sessions and we aren't able to code anymore. We got that down from over 80 tool calls to down to 6. That is so much cost in tokens, inference time that you can't get back.
Awesome, yeah, we'd love to open up to some questions if anyone has any.
Hi, thank you. I have a lot of questions. So I'm curious, is this going to be on a project basis? And how does this graph develop as you continue working on something and you have a huge repo? Is that actually going to slow things down? And then I have another question, which is, one project's failure might be another project's success. So how would this maybe work in a bigger company, or even for somebody that vibe codes and doesn't have a technical background. Like, is there something they could learn from this?
Yeah, no, absolutely. So we built this entire thing with enterprise in mind. The main thing right now with that curl command to install it, installs to just your project, everything runs locally on computer, we track nothing. But at an enterprise scale, all you have to do is host that database, the Postgres database and the vector database, up in the cloud, and you can share it between your team, your project, even an entire organization if you want to. As for kind of scope creep, like you mentioned, that would be, we have some temporal weighing. So if there's an issue that hasn't been resurfaced in a while, the confidence that that is going to continue to resurface starts to slowly diminish, meaning we populate it to the user less, and thus don't inject anything related to that one as frequently. Past that, I mean, we do have an archive system where, so say your coworker gets a promotion, great for them. Now you're stuck with all their work. They can export their entire graph of information right over to you. You can import it into yours, and immediately you have an agent that knows all of the issues that they've been facing and can pick up right from where they left off, and hopefully save you a little bit on that, Claude code, that quota there.
Maybe I missed it, but are you only saving like the tokens of the prompt, or are you also including the context in the knowledge graph you're creating?
Yeah, so the graph itself is specifically which agent spawned the task, what the error categorization was, the symptoms of that error, and then a suggested fix. The suggested fix is the only spot that we have external latency. That's from just a small Gemma call to Gemini's API. But everything else is just embedded into our vector database, and then we use that for the cosine similarity.
Could you tell them about how you're handling the subjectiveness?
The subjectiveness?
Because you do take input from the user, right? So
Yes.
I could be very pedantic, another person can be different opinion, and how do you handle it?
Yeah, so that's kind of the best part of the tool in my humble opinion. What we ended up doing is we don't force the model in any way. We don't force the agent, we don't block its tool calls. Even our prompt injection, that little like surgical injection we do, is super loose. We don't say like you have to do this or do this before you do this. All it is pretty much, hey, you've seen this issue before, and last time it caused these symptoms, and you solved it like this. Be cautious and just kind of double check your work. We noticed throughout our testing, that's really all of most of these models need, is just a little push in the right direction, and you just see just incredible improvements right off the bat. Thanks so much.